The parametric equations of the curve x is equal to 2 plus cos theta, y is equal to 3 plus sine theta. Find the Cartesian equation. Show that the curve is a circle with center 2, 3 and radius 1, and find the meaning of the parameter theta. C. Find the equation of the chord joining the points where the parameters theta is equal to 0 and theta is equal to pi over 2, and find the equation of the tangent where theta is equal to 3 pi over 4. Okay, so we got x is equal to 2 plus cos theta and y is equal to 3 plus sine theta. And in order to find the Cartesian equation, we need to find an identity to joining these two, cos theta and sine theta, and the obvious choice is obviously cos theta plus sine theta is equal to 1. So now rearrange this, so we're going to get that cos theta is equal to x minus 2, and that sine theta is equal to y minus 3. Substitute these into this, we're going to get x minus 2 squared, y minus 3 squared is equal to 1. B. This is actually an equation of a circle. X squared plus y squared is equal to r squared is the general form of a circle, but this has been moved where its center is 0 and the radius is r. So here we have a center of 2, 3 and a radius of square root of 1, which is 1. So this is an equation of a circle, center 2, 3, center 2, 3 and radius 1. So theta is the angle between the point being traced out and the center and the point 3, 3. We'll have a look at this when we're looking at it geometrically at the end. Right, to find the equation of the chord joining these points, theta and theta pi over 2. Obviously, if theta has a value, then we can get some coordinates coming out of this, and obviously we'll get another set of coordinates. So if x is equal to 2 plus cos theta and y is equal to 3 plus sine theta, when theta is equal to 0, we're going to have that x is equal to 2 plus cos 0, which is 2 plus 1. Cos of 0 is 1, which is going to give me the x coordinate of 3. And y is going to be equal to 3 plus sine 0, which is going to be 3 plus 0, because the sine of 0 is 0, which gives me 3. So we get 1 point, which is 3, 3. When theta is equal to pi over 2, x will be equal to 2 plus cos pi by 2, which is 2 plus 0, because cos of pi by 2 is 0, which is 2, and y will be equal to 3 plus sine pi by 2, which is 3 plus 1, which gives me the point 4. So we get the point 2, 4. So we're going to call this one x1, y1, and we're going to call this one x2, y2. Now the equation of the chord, so a line joining 2 points, is the bit of geometry that we need to use. So the formula for this is y minus y1, x minus x1, y2 minus y1, x2 minus x1. So it's going to be y minus 3, because x1 is 3, y1 is 3, x1 is 3, and we're going to have 4 minus 3, 2 minus 3. All these should be the same when we do this. So 4 minus 3 is 1, 2 minus 3 is minus 1, so all this becomes minus 1. So this will become y minus 3, bringing this up here, minus x minus 3. So we're going to have y minus 3 is equal to minus x. Minus times a minus is a plus 3. And therefore y will be equal to x plus 6. Minus x plus 6. Now, to find the equation of the tangent, so we've got x is equal to 2 plus cos theta. And y is equal to 3 plus sine theta. So dx d theta is equal to minus sine theta. Dy by d theta is equal to cos theta. So using the chain rule, so dy by dx is dy by d theta times d theta by dx. So this one you need to take the reciprocal. So this is going to become cos theta times times minus 1 over sine theta. So it's going to become minus cos theta over sine theta, which is cot theta, 1 over tan, minus cot theta. When theta is 3 pi by 4, the gradient will be minus cot 3 pi by 4. Right, so 3 pi by 4 is this angle here, so we've got to consider pi by 4. Tan of pi by 4 is 1. Okay, and tangent is negative here, so this will be equal to minus 1. Minus 1 is equal to 1. X is going to be equal to 2 plus cos 3 pi by 4. So cos of pi by 4 is root 2 over 2. And in this quadrant it's negative, so it's going to be 2 minus root 2 by 2. Okay, and y will be equal to 3 sine 3 pi by 4. So the sine of pi by 4, which is root 2 over 2, is positive in that quadrant. So it's going to be 3 plus root 2 over 2. So the equation of the tangent will be y minus y1 is equal to mt brackets x minus x1. So y will be equal to y minus y1, which is this one, 3 plus root 2 over 2, is equal to x minus x1, which is 2 minus root 2 over 2. So just to make sure that we've got that right, mt x1 and y1. Okay, so going up the top here, putting all this into brackets might avoid making a mistake with minus sign, so we're going to have y is equal to x, taking that in, minus 2, minus times a minus is plus, and then if we take all of this over to the other side, it just becomes plus because it's minus here, so it becomes plus 3 plus root 2. So we're going to have minus 2 plus 3, which is x plus 1, and then we're going to have half root 2, half of root 2, and half of root 2, which makes 1 root 2. So the final equation will be y is equal to x plus 1 plus root 2, approximately about 2.4. Okay, if we now go to GeoGebra, okay, so here we have the center of the circle. Here we have the starting point of the point P, which has here the angle 0. But if you see, if I move the parameter slowly, okay, we can see that the angle traced out, the parameter gives the angle traced out between this point, which is 3, 3, and the point being traced out, which is what I was trying to say. So what it does, it traces out a circle. To see it, you'd have to have the axes into 1 to 1. Okay, and then we get that point there. See it there. Okay, now we can add in, when theta is equal to 0, we get a point here, we knew that to be 3, 3. We can add a point here, and we know that to be 0.24. Okay, if I click this one, it will actually draw, this is the chord. Okay, and this will give me the equation of the chord, which is written in this format, x plus y is equal to 6. Same as what we got, y is equal to minus x plus 6. For the tangent, we know the tangent is when theta is equal to 3 pi by 4, so it's going to be somewhere over here. Okay, so if I just trace back to that point, you know, it's where that angle, we can't quite get to it. It's where that angle here is approximately 3 pi by 4. Okay, so if we draw the tangent at that point, we get the tangent. Okay, and we click here, we get the equation of the tangent. Okay, so you'll be able to play with this on the website if you want to. Okay, so that's the geometrical perspective of what we've just looked at analytically.